Hi, this is Mr. Kruns, and in this video we're going to talk about complex arithmetic. Now, complex arithmetic is not just complicated arithmetic, but it's an arithmetic that deals with a certain kind of number. And that a number arises when we get the square root of a negative number, such as maybe the most basic one, the square root of -1. Now, if you try to think about what a square root means, it means you're trying to find the number that if multiplied by itself, you get that number. So we're thinking of what number can we multiply by itself to get -1. So maybe start with a more simple example. We look at the square root of 9. And the square root of 9 is equal to 3 because 3 times 3 is 9. Right? Now if we come up with a square root of a negative number, our two candidates for answers are probably either 1 or -1. Now if you square 1 times 1 you get +1, so that doesn't work. And if you try a negative number, you get -1 times -1, which also turns out to be positive, because a negative times negative is positive. Therefore, with the numbers that we know about right now, we don't know of any number that can actually equal the square root of -1. Okay? So mathematicians had come up with this concept of a number called I. Right? And this I is called the imaginary number. Now, it might sound like something people made up, mathematicians made up, because we want to be able to solve problems that current numbers can't work with, and that it would have no connection to the real world. And maybe it seems like that, but it's actually not true. A lot of electrical engineering depends up heavily upon the imaginary number, though they sometimes call it J instead of I, but ends up being incredibly applicable to the real world. Right? Now let's do some math of this and see what it actually turns out to work. I'm just going to do one example here, but I'm going to make this one example have 3 different parts, so we kind of see 3 different things happening that we combine them all together. All right, the first part that we want to do is, well, for this whole problem, is to simplify this expression. Okay, square root of -36 minus I plus 2 squared, and then I'm adding on I to the 17th. Okay? For square root of -36, I need to simplify a radical. If you're not sure about how that process works with the regular numbers, make sure you go back and watch that video and make sure that's a skill that you've mastered. For square root of -36, I'm going to break this up into 2 different things. I'm going to break it up into the square root of 36 and the square root of -1. Alright, I'm doing this because then I can have one regular square root. Oh, I know that square root of 36 is just 6. And then the square root of -1, well, that's the number we just defined. That is I. Right, so this very first part, square root of -36, turns out just to be 6i. Now the second part, I have I plus 2 squared. You gotta remember that when I'm squaring a binomial, I have to multiply it by itself, not just apply the square to the different things within it. So this is like minus I plus 2 times I plus 2. Right. From here, I'm going to expand, so multiply. I get I times I get I squared plus 2I plus 2I plus 4. And if you notice that the I behaves a lot like a variable. We expand out and multiply. I times I gives us I squared. But now instead of I representing a quantity we don't know, it's just this imaginary number. Now I can actually even simplify this further. If I look at I squared, right, I want to kind of show you a little trick we have here. If I look back at the original problem here, original identity, square root of -1 equals I. If I were to square both sides of that, the square of the square root would cancel out. So we get -1. And then if I square the other side, I get I squared. So there's like 2 main things we get out of this. Is like, okay, the square root of -1 is equal to I, and if we have an I squared, it's actually just equal to -1. And I can use this right here to simplify my current problem. That I squared becomes -1. The two 2i's, I can combine those, get 4i plus 4. I'm putting all these guys in square brackets to make sure I'm subtracting this whole thing whatever it turns out to be. Simplify this last part. -1 plus 4 is 3. carry everything down so far. Alright, so these are the first two parts. I've simplified square root of negative 36 into 6i. I've simplified I plus 2 squared into 3 plus 4i. This last part, I have I to the 17th. So let's add this on the outside. I'll figure this term out. Now, I to the 17th, what we're going to do is simplify this so that either has an I without an exponent, or so that it is just some kind of number. To do that, we're going to take a look at a pattern. If I look at just the number I, that's just the square root of negative 1. Right? If I look at I squared, this would mean you square the square root of negative 1. We already talked about that up here. Turns out to be negative 1. Alright, and keep this going along. If I cube I, well, that's equal to I squared times I. It's using properties of exponents. I squared is negative 1 times I, and you get a negative I. If I go I to the 4th, alright, I to the 4th is equal to I cubed times I. Excuse me. Alright, now I cubed we figured out. Right here, I cubed is I. So that's a negative I times an I. Negative I times I gives me a negative I squared. I know what negative I squared is. I squared is negative 1. So I get a negative 1, which gives me just a positive 1. So I is equal to the square root of negative 1. So we keep that one as I. I squared is negative 1. I cubed is negative I. I to the 4th is just a positive 1. If we look at I to the 5th, I to the 5th is I to the 4th times I. We just found that I to the 4th is 1, which means that we have 1 times I, which is I. So we're kind of back to where we started down here. And then if we go through here, it actually just kind of repeats. I have I multiplied by, so we have this pattern. It goes, circle that one. I squared is negative 1, I cubed is negative I, we have positive 1, and then back to just I. And this is going to cycle a loop on through and through and through. So I look at I to the 17th, I want to figure out, well, what's that going to be? Okay. One way of doing this is I could try to predict, okay, is this going to follow some 1, 2, 3, or 4? Or I could also try to rewrite this using exponent properties a few times. So I'm going to say, you know what, I to the 4th is I to the 17th is say, maybe rewrite this a different way. Using exponent properties, we can rewrite I to the 17th as I to the 16th times I to the 1st. Alright, again using exponent properties, I'm going to take that 16th and turn that to I to the 4th times I. Okay. I to the 4th I figured out. I know that I to the 4th is positive 1. Right. Now 1 to the 4th is 1 times 1 times 1 times 1, which is just 1. Okay, 1 times I, and that's going to turn out just to be plain old I. Alright. Alright, now to simplify it, combine all these things, we only have either i's or numbers. So I have 6i. I'm going to distribute this minus here. Okay, minus 3, minus 4i, plus I. And now combine all the like terms. So all the plain old numbers, we get negative 3. That's actually it. And then count up my i's. I have 6i subtracting 4i to give me 2i, and then adding an I to get 3i. So this expression up here, negative square root of negative 36 minus I plus 2 squared plus I to the 17th, turns out to be equal to just negative 3 plus 3i. We call this process simplifying. This final answer has no exponents of i's, no square roots of negative numbers. It's just numbers and then imaginary numbers. So to kind of recap, what we did is we identified what would the square root of negative number be. So square root of negative 1 is equal to I. If we square that, we get I squared equals negative 1. And if you cube the fourth, you can actually recognize some patterns. Using those, we can simplify rather complicated expressions, such as this. Some of them will have negative square roots, which we can break up into the negative part, which is the imaginary number I, and the non-negative. So we've got a real answer here. Square root of 36 is just 6. Sometimes you might have like binomials or trinomials that were raised to a power. Works just like distributing and expanding, or what you guys might call foiling. I times I is I squared. You go on, simplify it on there. Or you might have like I to a really large power. We can break that up into different parts using exponent properties, then use the patterns with what I squared, I cubed, and I to the fourth are to break those down. So I to the 17th actually turned out to be equal to just plain old I here. At this point, we combine everything together and get our final answer.